Go. Hello everyone and welcome to the 10th challenge of Damn Vulnerable DeFi. Today we'll be taking on the free rider challenge. Let's go ahead and get into it. A new marketplace of damn valuable NFTs has been released. There's been an initial mint of 6 NFTs which are available for sale in the marketplace, each one at 15 ETH each. A buyer has shared with you some secret alpha. The marketplace is vulnerable and all tokens can be taken, yet the buyer doesn't know how to do it. So it's offering a payout of 45 ETH for whoever is willing to take the NFTs out and send them their way. You want to build up some rep with the buyer, so you've agreed to the plan. Sadly, you only have 0.5 ETH in balance. If only there was a place where you could get ETH for free, at least for an instant. Okay, so this is an interesting challenge, and there's quite a few moving components, so this may take us a little while to get through. But let's go ahead and have a look at it. The main thing, the first thing I want to look at is these two contracts here. So within this challenge, there's two contracts, the buyer contract and then the actual NFT marketplace. So let's have a look at the buyer contract first. And so this is actually deployed by the buyer who's offering out that 45 ETH bounty if you're able to get all the NFTs into this contract. So we can see here, let's have a quick kind of overview. There's some basic state variables here. We have a constructor, which sets the partner address, which is going to be the attacker address, and the NFT address, which is going to be the damn valuable NFT address that's been deployed. We have a look, we can see that on ERC721 receives, so there's a function here whenever this contract receives a token, it's going to go and make sure that it is the address of the NFT, so it's the correct NFT that's been transferred. Make sure that the origin is the partner, so the person who originated this transaction is going to be the attacker. Make sure it's between tokens 0 and 5 because there's 6 NFTs, and ensure that we own this NFT. If they have, and there's a counter of how many NFTs that it has received. If you've received 6, then send the payout. So our goal is basically to get to this line of code throughout our entire exploit. So, you could look into an exploit in this buyer payout contract. Unfortunately, it's not here. There may be one, but we're not going to be looking into that today. So let's go ahead and have a look at the NFT marketplace. So this one is, it's not too long. It's not too difficult. Let's have a quick look over it. So we have the damn valuable NFT, which is the deployed NFT contract, the amount of offers, the token ID to its price in terms of offers, 2 events. We can see in the constructor, it's going to mint an amount. It actually creates the new contract itself. So when this marketplace is deployed, it deploys another contract which is the damn valuable NFT, and it goes ahead and mints the amount to mint to this sender, which is going to be the deployer. In this case, I believe it's going to be 6. So we can see this is the WETH deployment contract. This is the token deployment contract. There is a Uniswap factory and router. So again, they're using Uniswap v2. We'll get into that in a little bit. And so this is all Uniswap stuff. Then we have the marketplace. So we can see it's deploying it with the amount of NFTs, which is going to be 6, which is defined up here. And it sets the marketplace initial balance as well. Okay, so then after this, there's a few different methods. So there's offer many, which is basically you own this NFT, so you're going to be able to offer all these up for a certain price. And I believe in the initial, it's going to offer many here of all the 6 NFTs that it owns for the NFT price of, I believe, 15 ETH. There we go. So each of them are going to be costing 15 ETH each. And each individual one, it'll be offer 1, which is a private function that goes ahead and offers it, basically. So it requires a price greater than 0. We must own the token. The token is approved this contract is approved to send this token on the owner's behalf, and then updates it there. And then we have another 2 functions called buy many and buy one, where you can buy many NFTs at the same time for the given offers, or you can buy one NFT. Well, actually, no, you can only buy many because buy one is a private function here, but you can just buy one by calling an array with a single value. So for each value in that array, it's going to call the buy one function, and it's going to go ahead and make sure you're paying the correct price and that you've paid enough. And then it's going to transfer from the seller to the buyer and then pay the seller and then emit the NFT bought event. So from here, this doesn't look too crazy. Let's go ahead and have a look at the setup of the challenge again. So we can see that there is a Uniswap factory and router and all this stuff that's getting approved and the initial token balance of the Uniswap liquidity pool. So we can see it's adding liquidity of ETH here and also the token. And we go through and we can see that this is all getting attached here. So where is the bug here, or how do we exploit this? What's the kind of way that we're going to approach this? So the first thing that we need to know is, firstly, we can't buy any of the NFTs. And the reason being is we only have 0.1 ETH. So we need to find a way, as hinted by the challenge at the top here, you can say if there's only a place you can get free ETH, at least for an instant. We want to get the ETH and then somehow then we can probably purchase NFTs. If we have a look at how much ETH is in the Uniswap protocol, let's have a look. So the initial token reserve in WETH is actually 9,000, so that's plenty. We should be able to borrow as much as we need to get all the NFTs. Now, I will say this is different to a flash loan. It's very, very similar, but within Uniswap, there's this idea of a flash swap, where instead of swapping for one token for another, you essentially request a flash loan and you want this amount of WETH or this amount of DVT in this case, and it will provide that to you. And again, it will have that callback function. And I'll go into a little bit more details of when we get into the code there. But even still, once we have all the ETH and we purchase everything, the transaction is still going to fail just because we're not going to be able to pay it back with the fee as well, because within the Uniswap V2 protocol, we need to pay that 0.3% fee. So, how do we fix this? How do we solve this? So the key in solving this is that there's actually two main exploits within this contract here. So if we have a look at buy one, let's have a look at what's going on here. The first one is, both these exploits are within the buy one function. So within buy many, there's the buy one, which gets called here. And within buy one, it verifies that the message.value is greater than the price to pay. And then it will transfer from the seller, right? So this kind of purchase has gone through. It transfers it from the seller to the buyer, and then it pays the seller. Now, the problem with this is that it looks up who the owner of this NFT is after it's done the transfer. So, for example, the buyer has now, owns this NFT after this line of code. So once this line of code runs and it looks up who the owner of the token ID is, it's going to be the buyer, which means that the payable here is going to transfer it's going to send the value, which is what we've just paid, to the buyer instead. So we're going to pay 6 ETH, and then 15 ETH, and that 15 ETH is going to come back and back into the buyer's wallet. So there's the first bug here. The second bug is to do with buying multiples. So, for example, say that I wanted to buy the NFTs with tokens 0, 1, 2, and 3. That means that there's 4 NFTs that I should buy, and that means I should be paying 4 times 15 ETH, which is around 60 ETH. So let's go through the flow and see how that would look like. If I wanted to buy 1, it would go through, buy number 0, and it will come over here and then make sure the price to pay is 0. It's correct. Is the message.value greater than the price to pay? Now, the price to pay is calculated from the offers array that's stored in the state. And this is going to be 15 ETH because that is the price to pay for this offer. And it checks that the message.value is greater than the price to pay, which is 15 ETH. So say I paid 15 ETH in my transaction to buy 4 NFTs. It's going to go, yep, that's fine. And then it's going to go ahead and pay us back anyway, so we get it for free. Then the next time it goes round, and again in this kind of second iteration of the for loop, we're buying a second NFT. The message.value is still going to be 15 ETH. However, the price to pay is also going to be 15 ETH. So it's not that we need to pay 30 ETH or 45 or 60 ETH. We just need to pay enough to purchase one NFT, and then we can purchase as many as we like. So the minimum requirement for us to fully exploit this is 15 Ethereum. Now, how do we do this? The way that we do this is by, again, utilizing the flash swap protocol to get the ETH and then to purchase it. Once we purchase it, once we have that 15 ETH, this is going to continually transfer from the seller to the buyer, which is going to be the same person, that 15 ETH. So when we send in the 15 ETH here, it's going to send us 15 and then 15 and then 15, which means that it's going to be actually profitable for us because we only send in 15 ETH, yet we're going to get 60 back, which nets us a total of 45 ETH in profit. Again, this is only with the 4. There is 6 NFTs in total, and we need to make sure that we're getting all 6 NFTs. All right, so we have a bit of an exploit overview now. Let's have a look at the free rider buyer again. So all we need to do essentially is find a way to transfer all the NFTs to this contract address. And ideally, we can do this in one transaction. So let's go ahead and kind of get into it. So the other thing that we're going to need to do is to do this in a smart contract. And the reason that we're going to need to do this in a smart contract is so that we can basically all do this in one transaction. So let's have a look at the smart contract solution here. So I'm going to go ahead and copy this, and we're going to create a new contract. I'm going to call it attack_freerider.sol. And so this is going to be our attacking contract here. So it looks quite complicated, but again, it's not too bad. So there's 2 functions that we have here. There's initiate flash swap, and then Uniswap v2 call. So in the constructor, we essentially just load up all the addresses that are relevant. So the WETH token, the factory, the DVT token, the buyer marketplace, the buyer contract, and then the NFT token. And then we all set them in the state variables here. So nothing too wild here. Let's have a look at Flash Swap here. So within Flash Swap, we first we set the token that we want to borrow and the amount that we want to borrow. So the first thing that we do here is verify in the Uniswap v2 factory. So this factory is set up here, that there is a pair between this token and this other token. In this case, we're needing to borrow ETH, and within the setup, it's a WETH DVT pair. You can see that here. So you can see the deployed token to be traded against WETH in Uniswap v2, and the deployed token is DVT. It requires that the address is not 0. So if there is a pair, then make sure it actually exists. Then within this pair, we use this interface here to make sure we get token 0 and token 1. So these are the addresses of token 0 and token 1, but we don't know which one is which. We don't know which one is ETH and which one is WETH. Sorry, we don't know which one is WETH, and we don't know which one is DVT. So we then work out which one we want, because we want to borrow the WETH as we have stated here when we did the pairing here. So we just go, all right, is the token the token borrow address the same as token 0? If it is, then we set it to the amount that we want to borrow, as in we want to borrow this amount of WETH, otherwise we set it to 0. And the same thing over here. The next thing that we want to do is encode the token borrow address with the amount again. This is just what we require to place in the Uniswap v2 pair address. Now, the reason that we do this is the way that the swap function works is usually in Uniswap v2, if you want to swap, token A for token B, you would have your amount 0 out and your amount 1 out, and then where you want that swap output to go. In this case will be the address of this contract. Now, this 4th parameter here is called data. And data is the determiner of whether it uses the whether it is a flash swap or not, essentially. So if this is empty, then it goes ahead and just does the transfers for you, and you need to make sure that you have transferred the equivalent back over to the Uniswap contract. Otherwise, the transaction will fail. Within data here, when this is enabled, you're able to call back to a custom Uniswap v2 callback. And the way that this works is that if this is populated, Uniswap will call back to a function in the contract called Uniswap v2 call, which is what we have implemented as the next function call. And that will call back with the sender, the amount 0, the amount 1, and the data. And this data here is going to be the exact same data that we've encoded up here. And we've just encoded the token that we borrowed address, which is going to be WETH, and then the amount that we borrowed as well. So we've initiated the flash loan. It goes to the Uniswap v2 address. We come back with the amount that we've borrowed, and now we can go ahead and handle our exploit. So the first thing that we do here is, again, we want to check which token that we actually got and how much we got of each one. Ideally, it should be that 15 WETH that we've requested, or the amount that we've requested. So again, we get token 0 and token 1, and then verify that the pair between token 0 and token 1 is the same as the sender. So it should be the pair address that's sending this in, and then the sender that was passed in from the parameter should be the address of the contract, because this was the contract that initiated the swap. The next thing that we want to do is decode the data that we encoded up here, just to make sure that we have the same token borrow amount and the amount that we borrowed. And this will be stored in token borrow and amount here. The next thing that we do is we calculate the loan repayment. So when we do a flash swap like this, again, there's that 0.3% fee. So we need to make sure that we calculate the amount that we need to repay as the amount that we borrowed plus that 0.3% fee. So we calculate that here as the fee, and then the amount that we need to repay, and then we save that in a variable. For the current balance, we then check that the WETH address the balance of this address in the WETH contract is valid, and we withdraw all this WETH to ETH. So because this is wrapped Ether and the actual exchange contract requires real Ether, we need to go ahead and withdraw that. So we do that by running a withdraw function here. And this is just using a ABI encode with signature. You could also do this by calling the WETH function directly, but I had some issues with Solidity compiler. So within this kind of challenge here, you can see that the WETH contract is using 0.7, whereas this contract is going to be using, it's 0.8. I haven't put it here, but all the other contracts are using 0.8. So that's why I had to use the encode with signature here to run the withdraw function. So now that we've withdrawn all the WETH that we've borrowed, we now have around 15 ETH to play with. So at this point, we can go ahead and actually execute on the exploit that we found in the free Rider NFT marketplace. So within the free Rider NFT marketplace, we need to firstly create a dynamic array that is of size 6 and load it up with all the token IDs that we want to borrow. The reason that we have to do this instead of just a fixed array is that they're different data types. And so when we are doing different data types and we pass in the token IDs here, when Solidity or the EVM is looking for which function to select, in the case that we want this by many function, it's going to look for one that's called by many and has a parameter of token IDs, which is of type this, which is a dynamic array, as opposed to a fixed size array, which will have a different function selector. And that will mean that the function doesn't get executed because it can't find it. So the way that a function selector works is essentially you get the ABI of it, which is going to be this, and then get rid of kind of call data and the name of the parameter itself, and you go ahead and hash that, and you take the first 4 bytes of that, and that's what's called your function selector. So then after we do this, we have this 15 Ether. we're going to go ahead and go to the NFT marketplace, and we go for buy many with a value of 15 Ether and with the token IDs from 0 to 6. Now, again, the reason this works is that one, we only need the minimum here because it checks it once each individual time. It doesn't detract from the message.value. And the second reason is because we will get paid back from the seller because it has been paid back. So from this 6 ETH, from those 6 NFTs that we purchase, we put in 15 and we should get 15 by 6 back, which will be approximately 90 ETH in return, which gives us a net of 75 ETH in value. Continuing along, we then, once we have these NFTs, we want to transfer the newly attained NFTs to the buyer contract. But before I do this, I want to go back here and come to the safe transfer from. So this safe transfer from method ensures that the receiving contract or the receiving address has a response that is of this format. So you can see on ERC721 received, you need to return with this ERC721 receiver on ERC721 received.selector. So you need to return the function selector called on ERC721 received. That is just what is required. You can tell because if we go ahead and check this out, we can go here. So safe transfer from, which is going to be here, which is going to do safe transfer, which is going to go here. And it's going to require that, this check on ERC721 received is correct or not. So that's why we need to do that. So then once we've done that, over here in our contract, we're going to receive this on ERC721 received to make sure that we bypass that check, and we just return the selector straight away. Okay, cool. We've now received all the NFTs. We then want to pass them over, because we want to do this all in one contract, to the buyer contract. So we just go ahead and we go each one, damn valuable NFT, safe transfer from this address to the buyer with the token ID, and we just loop through from 0 to 5. After we've done that, all this code will run, and eventually after the last NFT has been paid, we will go ahead and have this line of code run, which will send us the job payout value. After this is done, we need to go ahead and deposit all the ETH that we borrowed from Uniswap. So now that we have enough ETH to pay it back and plenty more, we have the 75 minus plus the 45 ETH payout. We have plenty to pay it back. So all we need to do is essentially ETH.call with a value of 15.1 Ether. The reason it's 15.1 is that that's the amount that we need to repay. We could actually just go ahead and put in the amount to repay here, so that would have been fine as well. And then we just go ahead and transfer the amount to repay back to the sender, and that's it. That's our entire exploit done. Once that's gone back, Uniswap v2 will approve the entire transaction, and we will have drained the entire marketplace. So let's go ahead and put this into code, and we'll go through this step by step again. This one isn't too complicated because most of the logic is actually based in the smart contract itself. So let's have a look at our code exploit here. So let's go ahead and start this. The first thing that we want to do is, as always, connect as the attacker to all these contracts. So we interact with them as an attacker, like this. The second thing is, again, we're going to have a helper function just to make sure that we can log the addresses and balances that we need as we're going through. So we're going to firstly log the initial balances of the attacker address just to see where we're at. The next thing that we're going to do is deploy our contract. So the reason we're deploying the contract, again, obviously, is we need to deploy it so we can run all that custom logic that we created in that contract. And then all we really do is run the flash swap. And that flash swap will go ahead and do everything that we need it to do, which is essentially, do the flash swap, get the money, go ahead and purchase the NFTs, transfer them back to the buyer, and then we should be good. And then after that, we can go ahead and log the balances afterwards to see where we ended up. Do note here that I have added a custom gas limit here. The reason being is I was just running into gas problems running this without that, especially when there's so many things that, Uniswap is running, and then that comes back to us, and then it goes to the other contract, and then it goes to the buyer contract, and then it comes back to Uniswap, and then back to us. So, there's a lot of gas going on here. It's a very expensive operation, so we're going to raise the gas limit here. Finally, we can go ahead and log the balances of the attacker. So, the success conditions. Let's have a look at what we need to do and just make sure that we have achieved all of them. So the first thing is that we need to have the balance of the attacker to be greater than the buyer payout. So we need to at least have got the buyer payout back, which is going to be that 45 ETH. We then need to make sure that the buyer contract address has equal to 0, as in we have emptied the buyer contract and we have hit that line of code saying pay our partner. The buyer then extracts all NFTs from its associated contract. So this needs to make sure that the owner of each token ID is the buyer address. So all NFTs are now owned by the buyer. The exchange must have lost NFTs in ETH. So it's going to verify that there's no offers available. So we've purchased all the NFTs. And it also needs to verify that the balance of the marketplace is less than the initial ETH balance. So again, if we have a look at the initial ETH balance of the marketplace, it's going to be 90. We pay it 15 initially, and then it pays us back the 90, which means it should have a remaining balance of 15. So once this is done, let's go ahead and run this and see if it all works. We're going to do yarn run freerider. And this will go ahead and compile, and we can see that it passes. And let's have a look at the how this all worked. So initially, we had the balance of the attacker being 0.5, the WETH balance of the attacker being 0. Then after everything has been completed, we can see that the ETH balance of the attacker is then 45, and the WETH balance of the attacker is 0. So yeah, that's the entire exploit. I hope you guys learned something and enjoyed this one. We're going to go ahead and get that green tick here. And I will see you guys in the next one when we cover backdoor. Awesome. Oh, it failed. No. Expected 5 to be greater than. Whatever. It's fine. This worked. See you guys. I'll catch you in the next one.